So today we're going to be working in assignment 2, which is on events. And so let's go ahead and get started. First of all, we need to know what a sample space is. A sample space is just a list of all the possible outcomes that could happen within a situation where we're going to be finding the probability. So for example, if we're flipping a coin, it could be heads or tails. And so we would list the sample space as either heads or tails, and that would be it. If we're rolling a dice, well, we can get a 1, a 2, a 3, a 4, a 5, or a 6, and that would be the sample space. Sometimes we list the sample spaces with a factor tree. Sometimes we can list it different ways, but it's just an organized list of everything that could happen. An event is a subset of those. Like it could be, an event could be heads. What's the event that you get a heads? It could be what's the event that you get a number less than 3, and so it would be like 1 and 2. It could be the event that you get an even number, so it would be 2 and 4 and 6. So it's just like a subset of the sample space, or a subset of what could happen. So let's take a look at some specific examples. If we have a deck of playing cards, it contains 52 cards. We want to identify the sample space of each of these situations. So let's start with event number 1. The event is that the card selected is the King of Hearts. Well, there's only one King of Hearts. Okay, so the sample space or that event would be just the King of Hearts. Well, if I had if the event was that I was going to select a card that was a king, well, then I have four different cards in that subset. It could be the King of Spades, King of Clubs, King of Hearts, or King of Diamonds. If the event was that the card selected is a heart, well, it could be the 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, or Ace of Hearts. That's 13 out of the 52 cards. That's 1/4 of them. And if the event was that the card selected is a face card, well, then it would look something like this. Here are all the face cards. And so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 out of the 52 cards are face cards. So if we went back to the ones where it was hearts, these 13 are hearts. If we went to just the kings, these 4 are just the kings. And if we specifically wanted the King of Hearts, it would be that one there. All of those are subsets of the sample space. And what you're looking at right now is a sample space of a deck of cards. So if you have a deck of cards and you tell somebody to select a card, these are all the possible things that could come when they select a deck of cards. So let's take a look at this notation. If I have not E, so if I have an event E, if it says not E, that means that E does not occur. So if the event is that I get a king, what is the event of not getting a king would be what this would represent, and that would be the other 48 out of the 52 cards that would not be a king. Then we have A and B. And so that would mean that it has to be both. So for example, let's say event A was that it's a face card and event B was that it is a heart. Well, the event A and B would be these 3 cards right here, because those 3 cards are both face cards and they're hearts. If I had A or B, well, that's a different thing altogether. Same situation with A and B, but in this case, if A represents a face card and B represents a heart, well, then it would be anything that's either A or B or both. So for example, it would include all of these right here. So these are all of the hearts and face cards, or both, because it includes all of the ones that are face cards and hearts as well. All right, so let's take a look then at how this would look like with the Venn diagram. So we have an event E, and so if I have an event E, that's what's in the circle. Not E would represent everything outside of that circle. So we're talking about the shaded part, the blue part. If I have 2 events, A and B, well, then this little football looking thing right here is the intersection, or we would say A and B. That's where both of them have to happen. That's this notation here. And if I had A or B, that's where it doesn't have to be both of them. It could be just A, or it could be just B, or it could be both of them. And so that would indicate A, B, or A or B. All right. So let's identify relationships among events. So let's identify the following events this way. A is that the event the card is selected is the King of Hearts. B would be that the event the card selected is a king. C is the event that a card selected is a heart. And D would be the event that a card selected is a face card. And so if we use those definitions, let's figure out what not D would be. Well, D is the event the card is a face card. So this should be anything that is not a face card. B and C would be anything that is both a king and a heart. So it would have to have a king and it would have to be a heart. There's only one card that would satisfy that condition. That's the King of Hearts. So it's a lot different than B or C, because B or C would be anything that's a king or anything that's a heart or the King of Hearts itself. That includes both. So that's what B or C would be. And then finally, if we say C and D, we'd want to have, the C is that the card selected is a heart, and D is the card selected is a face card. So we'd have to have a face card that is also a heart, and that would be these three cards here again: the Jack, the Queen, and the King of Hearts. All right. So let's take a look at what mutually exclusive events. We're still on the idea of events. We've identified what an event was. We talked about not an event. We talked about two intersection of events, so A and B. We talked about A or B, which is called the union of two events. And here we have two mutually exclusive events. Mutually exclusive events is that two events where no two of the outcomes are in common. So for example, this would be an example of two mutually exclusive events. We have event A that could happen. We have event B that could happen, but there's no way for something to be in both of those events. They're mutually exclusive. Okay, you can't do both. Okay, that would be like somebody saying they're in the 12th grade and somebody else saying they're in the 9th grade, and the same person saying they're in the 9th grade. You're either in the 12th grade or you're in the 9th grade. You can't be both. Those are mutually exclusive events. Well, if we look at this Venn diagram, these are not mutually exclusive events because you could be both. So this would be like somebody saying they drive a car and they're a senior. Well, you could be both. Those are not mutually exclusive events. Then we could have three events. So here in the picture of A, we have three mutually exclusive events. So you have A, B, and C. You can't be in two of those even. You can only be in one or the other. That would be like either you're a junior, you're a senior, or you're a sophomore. Okay, you can't be in two of those groups. You're in just one of them. Those are mutually exclusive events. Then we have non-mutually exclusive events in part B. So that's where there can be an intersection of all of those. You can be in A and B, you can be in A and C, you can be in B and C, or you could, if you're right in the middle, you could be in all three of those events. Even part C is non-mutually exclusive events. They're not mutually exclusive because you could be in both A and B. So we're going to get into mutually exclusive events more as we go on through the assignments that are in this unit. But we just need to know the definition right now, which is that if you have mutually exclusive events, that means you cannot be in both of the two events. That's 4.2. And there's a homework assignment in Math Excel, and we need to get that finished, and we will see everybody tomorrow in class.